G'day, and this video we're going to look at some operations on vectors, adding them, multiplying them, that sort of thing, to see what happens. So here we go. I've just got a little VetSim open up here, and I'm just going to pull out a vector and just draw one on the screen. Okay, so I'm just going to manipulate it, something like that, and yeah, something like that, that'll do. Now, so I've just put a vector here. It's got a magnitude of 17.7. It's got an angle of 16.4, so that's just from the horizontal there, so 16.4 degrees. It's telling me that Rx, which is just telling what's the x component, in other words, how long is that there, the horizontal component of that vector, and what's the vertical component. It's got a vertical component of 5, and you see if I move that around, then you can see the number changes. I make the line longer, the magnitude gets bigger. As I turn it around, the angle changes, and that's the direction of the vector. You also see the horizontal and the vertical components changing as I change this. So I might just leave it like that. And there's our vector. Now I'll just put on some components, and you can see here the two components. The horizontal component here is 13 units, and the vertical component is 6 units there. So there's our two components, and if I change this style, it shows you, there you go, on the x-axis there, that's the x component, there's the y component of this particular vector. And if I move that around, you'll see how the y component changes. It doesn't matter where I go, you can write any vector as the two components added together, this component plus this component. So there we go. I'll just put that back to that one there. It's a bit more obvious. Okay. Now, if I put another vector onto here, what happens when we add two vectors together? So in other words, if I just make it a bit smaller, something like that, and I'll put the tail of this vector on there, and I might just put it up something like that, then what we've got is we've got two vectors here that I've put on the screen. So what happens when you add two vectors together? This vector plus this vector. Well, this is what happens here. If we add them together, we get the sum, and it's thrown it over here. This green vector here is the sum, what's happened. But what it is actually is, if I place it here, if you add this vector to this vector, the sum of those vectors is just the triangle, or the, you could call it the shortcut from here to here. So the tail to the head of this one, the tail to the head of this one, becomes the tail to the head if you add those two vectors together. And if we move this, I can sort of move that to different sizes and that sort of thing. You can see how it doesn't matter where I place this second vector that I did, the sum of the vectors, the green one, moves around with it. It always stays like that. So basically that's how we go. And if I move it over here and put these components on, you can sort of see what's happening if you can understand this. This first vector was made up of these two purples, so a x component and a y component. This second vector that I placed on here has an x component and a y component. And you can see that the sum of the vectors is purely just the sum of the x components of both, so this plus this, and the y component of the sum of the vectors is just the sum of the y components of the individual vectors, so this plus this. And so the way that we add vectors together is just by adding the components. So if we have two vectors, let's just say we've got vector A, and that's as a column vector, that was 2 and 5, and we have another vector B, and that vector is, oops, let's screw that up. We've got a vector B, and that is 6, 6 and 1. And all we have to do, if we've got we want to add those two together, we just add the components together. So adding the x components, 2 and 6, 2 plus 6 is 8, and 5 plus 1 is 6. And so that is our new vector when we add them together. And this just makes sense. A to 5, so that means it goes across 2 and up 5, so that's vector A. And vector B goes across 6 and up 1, so it goes across 6 and up 1, so it looks like that. That's 6, that's 1, this is vector B, don't forget your tildes. A goes across 2 and up 5. Then you can see that the total vector here, I'll try and be clever and put it in a different colour. This total vector here, that's your sum there, that is A plus B. And to find out what A plus B is equal to, well, what is it equal to? How far does it grow across? It grows across 2 plus 6, 8. How far does it go up in total? It goes up 5, and it goes up a further 1, so it goes up 6. And so that's why when we've got vector addition, we just add different components together. Okay, so now let's have a look at what happens when you subtract. So let's just clear the screen. What happens when you subtract? Well, maybe I should do multiplication first. Let's do scalar multiplication. Now we're going to multiply vectors by a scalar. So let's say we've got A, and that's some vector 2, 3. So we've got, it goes across 2 and up 3. We've got a vector A. Okay. What happens when we multiply a vector? So let's say, what is 2A? If we multiply that by a scalar, 2 is a scalar, what happens? Well, it ends up being, we just multiply each of the components by 2. So 2A will be 2 times 2, which is 4, 3 times 2, which is 6. So that's what 2A looks like. What does that mean? It means it goes across 4 and up 6. So we have this vector here, 4, 6, this is 2A. So what has it done? What has multiplying by a scalar done to our vector A? Well, in other words, all it's done, it's left the direction exactly the same, but in fact it's multiplied the magnitude by 2. And so that's the effect of multiplying a vector by a scalar. The only time the direction changes if you multiply it by a negative number. So negative 3A will be equal to, if we multiply everything inside here by negative 3, you get negative 6. 3 times negative 3 is negative 9. And so what happens is you get this, I'll start from up here. So we go across negative 6, it's going to go across here, negative 6, and then it's going to go down negative 9, so down in this direction, so something like that. So it's going to be down like that, and that'll be negative 3A. And so what's happened is it's gone across negative 6, down negative 9. If we multiply something by negative, it actually changes the direction. They are still parallel. All of these three vectors are still parallel, but what the negative has done is it's changed the direction. It's exactly the opposite direction of these two vectors, and that's an important thing to realize, that when you multiply by negative it changes the direction of the vector, but the direction is still they're all still parallel to each other. Very important. So now let's have a look at what subtraction. Now that we've sort of done that, let's have a look at subtraction. Subtraction. What does it mean to subtract two vectors? So let's do A minus B. And we'll say that A is equal to 1, 3. I pick pretty boring numbers, sorry about that. And don't forget your tildes, I always do. B is equal to negative 2 and 7, something like that. Okay. So let's have a look at this. I shouldn't choose such big numbers. Let's just make that a 4. Sorry, that's a 4. Otherwise I'm going to go off the screen. So A is 1, 3. So it goes across 1, goes up 3. So there's our vector. 1, 3, there's A. Now B is negative 2 and 4. So I'll just I'll draw it over here. What should I draw? Oh, I'm going to subtract, so I'll just draw it here. So negative 2, so it goes across negative 2 in that direction, and it goes up 4. Oh, I'm going to get close here. So that's B. Okay, so that goes negative 2 and 4. And I should have left a bit more space. Anyway, there's A and there's B. So that would be, if you added A plus B, you'd get something like this over here. A plus B. That would be A plus B. over there. But we want a minus b. So what does minus b look like? Well, if you remember, if you multiply something by -1, it changes the direction. Okay, so so a minus b will be a. You can think of it as the same thing as a plus negative b, if you want to think of it like that. So what is negative b? Negative b is exactly the same as b, but in the different opposite direction. So in fact, it's going to go in this direction. Oh, what have I done? Got to be careful. Just still learning this new technology. I'll just start that again. It's got these little buttons on it, these pens, that sort of do weird things, and so that's no good either. Got to be a bit more careful. So b will be in the opposite direction. In fact, what b was, instead of going that way 2, it's going to go this way 2, and instead of going that way 4, it's going to go this way 4. So what's happened here? Well, it looks a bit strange. Instead of b going in this direction, it's going in the opposite direction because it's negative. Okay, so that is actually, that vector there is actually negative b. What happens when we add them together? You'll get the resultant vector. I'll do it in green. You get this resultant vector here. So you have a plus negative b, and you'll end up with this green vector here. That is actually a minus b there. And so that's the theory of it. And so what is this vector? Let's just have a careful look at this. What is a minus b equal to? So we've got a. Now what happens here? It goes across 1 and up 3. So it goes across 1, up 3, and then it goes in this direction. It goes across. So we'll just do the horizontal components. It goes across 1, and then it goes across another 2. In other words, it goes across 1, and then it goes across another 2. In other words, it's become positive. So 1 minus negative 2. Because b was negative 2 there. What's happened to the vertical components? Well, it's gone up 3, and then it's gone down 4. In other words, it's gone negative 4. So it's gone 3 minus 4. In other words, if you're trying to add any two vectors, subtract any two vectors, all you do is subtract the components inside there. In other words, 1 minus negative 2 and 3 minus 4, exactly like here. So the resultant vector, when you're subtracting, 1 minus negative 2 is 3, 3 minus 4 is negative 1. Our resultant vector is across 3 and down 1, like that. And that's how we subtract two vectors. And basically, that's the most sort of, if you understand addition, subtraction, and scalar multiplication, then you're doing well. More in the next video.